Hello, you guys. Let's talk about 7.4. And I'm going to try to play tug of war with my dog and do this at the same time. Okay, so vocabulary. A relation. A relation is every x value has a y value partner. So they're kind of like a partnership. An x value matches with the y value. Now, domain and range. Look over here. Remember when we were doing in chapter 6 the tables with x values and y values, and then we were graphing them? Well, we're going to do that again. They just want to add some vocabulary. Another name for x values is called domain, and another name for y values is called the range. And my algebra class used to think of it as a doctor. The abbreviation for doctor is DR. So D comes first and then the R. So the domain is all the x values, or they also call them the input values, because you would take the x value and put it into the problem. And the range is all the y values, or the output, the answer. So input is all the x values, output is all the y values. Now in a function, each x value, each input must have a different output. So you can't put in the number 2, for example, and get one answer, and then put the number 2 in again and get a different answer. That's not a function. That's a relation, but it's not a function. And linear function, notice how I underlined the first 4 letters, L-I-N-E. That just means, remember, linear means it's always going to form a straight line. Okay, take a look at example 1. Use the information in the table that shows the ages and weights of 5 toddlers. So toddlers are little babies, but they're old enough to start walking. Okay, so take a look at this. So age in years is the X, the first one. So remember, the X is always the D in the doctor, the first letter of the abbreviation for doctor. And the weight is the Y value. It's always the second one, and that's the range. So a 1-year-old, they measured their weight and they were 20 pounds. A 2-year-old, they measured that toddler's weight and they were 22 pounds. Another 2-year-old could weigh 26 pounds, and that's true. You know, they have different weights. A 3-year-old was 34 pounds and a 4-year-old was 40 pounds. And so the first thing they want us to do is identify the domain. Remember, the domain are all of the x values. And so take a look here. The domain is the set of all the inputs, or x values. And so I would write 1, and then notice how the 2's repeat. Well, if they repeat, we only write it once. So I'd write 1, then 2 just once, then 3, then 4. Now the range is all the y values, and we're supposed to put them in order from smallest to largest, and they're already in order, which is nice, but then we'd write 20, 22, 26, 34, and 40. And now they want us to represent using a graph. So if we're going to use a graph, we want to put one x with one y. So I would put 1, 20 is the first point I would graph. So I start at the origin at 0, 0. The 1 tells me to go to the right 1, and the 20 tells me to get in the elevator and go up to 20 and then put a dot. And then the second point is right here, 2, 22. So I start at the origin, I go to the right 2, and then I go up to where I think 22 is, and I put a dot. And then I have to graph 2, 26, so I start at the origin, the 2 tells me to go to the right 2, and then go up 26, and I put a dot. Then 3, 34, so start at the origin, go to the right 3, and up 34, and put a dot. And then 4, 40, so start at the origin, go to the right 4, and then up 40. And the graph shows me something. See, if you were thinking kind of like Slope Guy, that he would have to go up, up, up the mountain. So this is showing me that a toddler's weight tends to increase as they get older, and that makes sense. Okay, look at example 2 to identify a function. Because the input 2 had 2 outputs, remember, one of the 2-year-olds was 22 pounds and a different 2-year-old was 26 pounds. That means the relationship is not a function. And remember, it makes sense because 2 toddlers of the same age, so 2 2-year-olds, could have different weights. Now I'm going to explain this a lot more on the extra notes on the next slide. So you're going to take some extra notes down at the bottom of the page. But right now I just want you to know that if an input has 2 different outputs, that means it is not a function. Okay, and then take a look here for the guided practice. For each of these relations, they want us to first identify the domain and the range, and then they want us to use a graph, and then they want us to tell if it's a function or not. Okay, so take a look here. They gave me 4 points. -5, comma 2, so I start at the origin. -5 tells me to go to the left 5, get in the elevator, and the 2 tells me to go up 2 and put a dot. And then -2, comma 5, so get in the origin, go to the left 2, get in the elevator, and then go up to 5 and put a dot. And then -5, comma -2, so I start at the origin, I go to the left 5, and then get in the elevator, go down 2, and I put a dot. And then 2, comma 5, so I start at the origin, I went to the right 2, and then I get in the elevator and go up 5 and put a dot. Okay, so I graphed it. Now, I want you to talk to me about the domain. Now, I think it's easier when they give you a bunch of points like this, put it in an X and a Y table. So notice how -5, comma 2, I put -5, 2, -2, 5, I put -2, 5, -5, comma -2 I put here, and 2, comma 5 I put here, because it's easier for you to see the domain right here when you see all the X's together. Now remember, you want to put a capital D for domain and a colon, and then we have to take these numbers and organize them from least to greatest. See how -5 repeated? I'm only going to put that once because that's the smallest value, and then I put -2, that would come next, and then the biggest number there is +2, so that's my domain. Now the range are all the Y values, and again you want to organize them from least to greatest. So -2 is the smallest number, I put that first, and then +2, and then the 5's repeated, so I only write it once, +5. Okay, now here's the deal. See how this point is right on top of this point, and if I drew a vertical line, they would be right on top of each other? That is not allowed. So that's why it is not a function. It is right here. Now if you're looking at the table, if you want to look at the table without graphing it, you always look to see if any X values repeat. If any X values repeat, then it's not a function. Okay, take a look at number 2. Now this one was nice because they organized it in a table. The input, the X's are right here, and then put the D for domain. The output, the Y's are down here, put range. And so let's graph it. 0, comma 1, start at the 0, don't go right or left. The 1 tells you to get in the elevator and go up to 1 and put a dot. 1, 2, I'm going to start at the origin. I went to the right 1 and up 2 and put a dot. 2, 3, started at the origin, went to the right 2 and up 3 and put a dot. And then the last point, 3, 4, I started the origin, I went to the right 3 and up 4 and put a dot. Okay, now to write the domain, look at all the X values and put them in order from least to greatest. They're already in order and nothing repeats, so I just put 0, 1, 2, 3. For the range, that's all the Y values, just put them in order, 1, 2, 3, 4. Okay, now notice something. See how there are no points stacked on top of each other? Then that means yes, it is a function. Okay, so there's a quick test to see if something's a function, especially if they give you a picture of the graph. And they call it the pencil test. But you have to hold your pencil straight up and down like a vertical line, like Slope Guy going, ah, and falling, okay, that kind of a line. So if I had this graph, and I want you to draw this, draw the X-axis and the Y-axis, and then with your blue, just do this little wavy graph. So if I had this graph and I wanted to test it to see if it was a function, I would hold my pencil straight up and I would make sure that my pencil only touched the graph in one spot no matter where I moved it. And since no matter where I move it, it only touches in one place, then you could say, yes, that graph is a function. Now take a look at this one. I want you to draw the X-axis with your pencil or black pen, the Y-axis with your pencil or your black pen, and then with the blue I want you to draw this shape, okay, this curve. And I want you to notice something. If I had my pencil straight up and down and I moved it, do you see how it would touch the graph in two places? If it touches more than once, it is not a function, okay? And then take a look at this graph. I want you to draw your X-axis and your Y-axis, and then with your blue pencil I want you to draw one line segment, and then right below it draw another line segment, like stair steps kind of. And then if you took your pencil and you held it up, do you see how these 2 points stack right on top of each other? If that ever happens where the pencil would touch 2 points of your graph, then it is not a function. Okay, so let's try example 3. Which graph best represents the total amount you are paid as a function of number of hours you babysit, okay? So the X is the number of hours and the Y would be how much money you make. So the first thing I would do if it's a multiple choice is look at the X and the Y axis. See how this X axis is hours, so that's good. See how this X axis is hours, that's good. See how this X-axis is the amount of money, so that's bad. So I'd immediately cross out choice C. And then look at D, the X-axis is hours, so that's good. Okay, now I want to look and make sure the Y-axis is the money. So here the Y-axis is the money, here it's the money, and here it's the money. So those are all good. Now the other thing I think is just use common sense. If you babysit 0 hours, you don't get paid anything, right? So you want to make sure the graph goes through 0, 0. So here the graph is at 0, 0. That's good. Here the graph is at 0, 2. That means they're going to give you $2 when you haven't even babysat a single solitary second. I don't think so. So cross that one out. And then here, again, they're going to give you $2 even though you haven't done anything yet? I don't think so, okay? And so cross that one out. So really the only thing that makes sense is choice A, that if you babysat an hour, you would make some money, $1, 2 hours, $2, 3 hours, $3, and so on. This is the only one that really makes sense, and they explained it down here. Okay, take a look at this guided practice. Sketch a graph that could show the temperature of a cup of hot water as a function of time. All right, so time is the X and the temperature is the Y. So right away on the X axis, I want you to label it time and it'll be in minutes. And the Y axis, I want you to label it temperature and that'll be in degrees Fahrenheit. And so I had my husband measure the temperature of, he made me a special coffee drink, and so we measured it to see, and it was about 160 degrees. So we started off with, at 0, it was 160 degrees. And then after a couple of minutes, you know how it cools off, so we put it was about 150 degrees. After 4 minutes, it cools off, so let's say that's about 130 degrees. After 6 minutes, it cooled off, it was about 100 degrees. After 8 minutes, it cooled off, it was about 70 degrees. And then if I just left it alone, you know, it cools off, okay? So we just graphed this for you to show you what would happen. And that makes sense. Remember Slope Guy, if he was here, he'd ski down, down, down that mountain, so it would be negative. So that means the temperature of a cup of hot water will decrease over time. Okay, guys, and just lightly cross off example 4 because we're done with this lesson.